Here's something that doesn't make sense at first. AI companies sell you software subscriptions, monthly fees, per-seat pricing, the familiar SaaS playbook. But underneath, they're running something closer to a power utility or a manufacturing operation. Every time you press enter on a chatbot, somewhere a cluster of GPUs is burning electricity and wearing out silicon. The gap between what you pay and what they spend is where the entire business lives or dies. This isn't a detail, it's the defining feature of the industry, and it explains why AI products work the way they do, why some companies win while others quietly suffocate, and why the next decade of software will look fundamentally different from the last one. Let's start with what these businesses actually are. A traditional software company builds something once, then sells copies. The marginal cost of each new customer approaches zero. That's why software margins can hit 80 or 90%. AI companies don't have this luxury. Their product is compute intensive every single time. The same prompt to the same model costs roughly the same amount today as it did yesterday. There's no manufacturing efficiency curve that makes the 100 millionth query cheaper than the first million. This creates a structural problem. Revenue scales with customers, but so does cost. The classic software flywheel, acquire customers, pour money into growth, watch margins expand as you scale, doesn't apply in the same way. You can grow yourself into bankruptcy if you're not careful. So what do AI companies actually sell? They sell access to scarce compute, wrapped in interfaces that make it feel like software. The interface is the distraction. The GPU reservation is the product. This explains the pricing models that dominate the space. Tokens, characters, minutes of audio, compute hours. These aren't arbitrary choices. They're attempts to align customer demand with supplier cost in something close to real time. When you buy 1,000 tokens from an API provider, you're not buying software. You're buying a fraction of GPU time, pre-negotiated and abstracted into something easier to reason about. Now let's look at how this mechanism actually works in practice. The first thing to understand is utilization. A GPU sitting idle is pure cost. No revenue, all depreciation. This creates a scheduling problem that dominates operational decision-making. AI companies live and die by how well they pack demand onto their hardware. Too little demand, and your margins evaporate. Too much, and you queue customers or buy expensive spot capacity from cloud providers. This is why usage-based pricing isn't just a preference. It's a survival mechanism. It lets demand signals flow directly into capacity planning. Customers who use more pay more. Customers who use less cost less to serve. The alternative, flat-rate subscriptions, requires predicting usage patterns with precision most companies don't have. Get it wrong, and a small number of power users destroy your unit economics. The second mechanism is model selection as cost management. When you interact with a modern AI product, you're rarely hitting the most capable model every time. Behind the scenes, systems route queries based on estimated complexity. Simple questions go to smaller, cheaper models. Complex reasoning escalates to larger ones. This routing layer is invisible to users, but essential to margins. It's the equivalent of a factory manager deciding which production line to use for each job. The third mechanism is caching and memorization. Many AI queries are similar to previous ones. Smart systems store and reuse outputs, avoiding redundant computation. This looks like a technical optimization. It's actually a financial necessity. Every percentage point of cache hit rate flows directly to the bottom line. The companies that build sophisticated caching layers can offer competitive pricing while maintaining healthier margins than those that don't. The fourth mechanism is the multi-tenant architecture. Cloud providers sell GPU access in slices. An AI company might rent an 8 GPU server, then subdivide it across hundreds or thousands of customers. The efficiency of this subdivision, how well you pack users without them interfering with each other, determines your gross margin. This is operational excellence in its most concrete form, not marketing efficiency, not sales velocity, physical packing density of computational workloads. Now we need to talk about why all of this matters beyond the companies building these products. It matters because it reshapes what users should expect, what investors should value, and what competitors should prepare for. First, the user experience. AI products that feel magical often do so because they're subsidizing your usage. The free tier isn't just marketing. It's a bet that you'll convert to paid, or that your data will improve the model, or that your presence helps attract enterprise customers. But subsidies can't last forever. The products that survive will be the ones that find sustainable ways to deliver value without burning cash indefinitely. This means interfaces will change. We'll see more explicit trade-offs between quality and cost, more tiered models where users choose their own price performance point, more products that feel less magical but are actually viable businesses. Second, the competitive landscape. Traditional software moats, network effects, switching costs, data gravity, still matter, but they're joined by a new one, operational efficiency at scale. The company that can serve 1 million users on 10% fewer GPUs has a structural advantage that compounds.
This favors incumbents with existing infrastructure and capital to deploy. It raises barriers to entry. It means the AI startup boom of 2023-2024 will consolidate faster than previous software waves because the economics don't support long runway periods with negative margins. Third, the talent market. Building AI products require different skills than traditional software. You need people who understand hardware procurement, spot pricing dynamics, model serving optimization. The engineer who can reduce inference latency by 20% is worth more than the one who ships features twice as fast, because that latency reduction translates directly to cost reduction at scale. This shifts power within organizations. Infrastructure teams become product teams. Cost centers become profit levers. Fourth, the platform dynamics. The companies that own the GPU layer, NVIDIA, the cloud hyperscalers, emerging challengers, capture an enormous fraction of value in the AI stack. Everyone else is negotiating against them. This creates pressure towards vertical integration. The AI companies that survive will likely build or acquire their own infrastructure, or find ways to reduce dependency through model efficiency, specialized chips, or clever software architectures. Finally, the regulatory and environmental implications. GPU clusters consume enormous energy. The locations of data centers, the sources of their electricity, the carbon intensity of inference workloads, these become business questions, not just ethical ones. Customers increasingly ask. Investors increasingly measure. The AI company that solves for sustainable compute may find advantages that pure performance optimization misses. So what should you take from all of this? If you're building, understand that your unit economics are not software economics. Price for the cost structure you have, not the one you wish for. Build operational excellence into your culture from day one. If you're investing, look for companies that talk about utilization, caching, model routing, not just model capability. The best model poorly operated loses to the adequate model well operated. If you're using these products, recognize that the current generation of interfaces is transitional. The sustainable versions will ask more of you, more explicit choices, more understanding of trade-offs, more willingness to pay for what you actually use. The AI industry is maturing from a technology demonstration into an infrastructure business. The companies that thrive will be the ones that stop pretending they're software businesses and start operating like what they actually are, sophisticated managers of scarce computational resources, delivering value through interfaces that hide complexity without hiding cost. The mask is software, the machine is GPUs. The winners will be those who never confuse the two.